So we're back in Math 1, and we're going to do the exercises where we're combining a quadratic and a linear. And so this is a nice exercise for you to see that you're both working in X and Y, and in fact you can solve them simultaneously. So in the past we had two lines and we found where they met at one point, and now you're seeing that we can have a line and a parabola, and they can meet at 2 points. And this was indeed what was on the test. There was kind of an easy way to figure out the answer because they gave you the 4 possible points, so you could just plug them in. But we want to get a little bit better at it and just see if we can figure it out in such a way that we don't have to plug in. Okay, so let's lock the rotation on this and go in and say, oh, we've got this nice upward facing parabola and it's already drawn for us. So all we have to do is draw the linear equation 2x plus 1 y equals 2x plus 1. And so the easiest thing to do is just say, well, what's the y-intercept? 1. What's the slope? 2. Okay, so we say 0, comma 1 is right there. And slope is 2. So we go up 2 over 1, up 2 over 1, up 2 over 1. So it's very close right there, right? Okay, and then let's see. So we go, what else do we do? Well, we go down 2 over 1. So not quite. It's going to cross down there. So let's enlarge it a little bit and put in our line. And so it seems to go through there, and we'll do a nice green line here. Okay, and so it looks like we have a lattice point. At one point, we say it's, let's say, so it's 1, 2, 3, 7. So this looks like 3, 7 is a point. Then back here, it looks more like minus 3/4 minus a half. Those look like the points just by using the graph. And so let's remember, what did we do? So we said we can set these equal to each other. 2x squared minus 3x minus 3 equals 2x plus 1. And in doing so, we say, well, we're going to subtract from both sides so that we'll just have our terms on one side. And that gives us 2x squared minus 5x minus 4 equals 0. Okay, so when you look at this, you say, oh, I've got that dreaded case where I have 2 of something. And so how can I get what I want here? And it looks like, well, perhaps I can't factor it. All right, when you look at this, can you factor it? You say, I don't think so. I can't factor this. And what do you do then? So you say, well, I'm not sure what to do. So 3 and this. You can hear me. I'm just using technology a little bit here to see if I can figure it out as well. Yeah, so it seems like points are rational numbers. And so we say, well, let's see what we could do. So what are some of the things that you could do here? And so I think first thing I might try is I might try and just divide by 2 and see if that gives me any help. So I try dividing by 2, and I get x squared minus 5 halves x plus 2 equals 0. All right, so then I say, well, maybe Okay, so remember, what did we have to do? So we had to figure out, well, what is this going to be? Okay. So we need half of that. I guess it's fourths, right? So it's going to be minus 5/4. And so we got x minus 5/4 squared. But then we have to complete the square. And I say, okay, well, what would that be? So it's going to be 25/9. Okay, and so we say, well, let's just plow ahead with this and see where we go. And so we said that's going to be minus 18/9 plus 25/9. So let's find a nice color to work with here. About pink? How about purple? So we say x minus 5/4 squared equals 7/9. Okay, so what do we usually do in this situation? So you remember what, well, we said we can always take the square root of the right side. So let's take the square root of the right side and the square root of the left. So second, let's take the square root. And so, oh, x minus 5/4 equals the square root of 7, not square root of 3, square root of 7 over square root of 9, which is 3. Okay, and don't forget that's a plus or minus. So then we have, well, what else do we have? We have x. So we'll add 5/4 to both sides. So we'll get x equals 5/4 plus or minus square root of 7 over 3. Well, that isn't a very satisfying answer, is it? And but in fact, uh, that seems to be the case. Right? So we didn't quite hit at the last points. And so that's the danger when you try to solve these and just kind of make them up. And so you say, well, what about y, right? Well, we can just put this in. So we say y equals 2x plus 1. Okay, so once we're down this path, right, we have to go. So 2 times 5/4 plus square root of 7 over 3, or y equals 2 times 5/4 minus square root of 7 over 3. So what would your answer be? So your answer would be whatever this is, right? So this is what, 10/4 plus 2 times square root of 7 over 3. And so that was with 5/4 plus. And, you know, so you could combine these if you wanted to, I guess, over square root of 7 over 3. Okay. So that got pretty ugly, didn't it? And that's just something that happens with quadratics, right? So you like to live in this nice land where, you know, everything's whole numbers. Oh, and then I didn't do it right? So it's 2x plus 1, right? So this thing plus 1 and this thing plus 1. So 10/4 minus square root of 7 over 3 plus 1. Yeah. Well, that wasn't very satisfying, was it? And let's try this one. Maybe we'll have better luck and get some points on this. So we look and we say we want to plot y equals minus 2x plus 3 and see where that intersects. And y equals minus 2x plus 3. And they're going along and think, well, always try 0, right? So let's just say x and y. So if we put in 0, we're going to get 3. So we say 0, 3, 1, 2, 3. So there's a point. And our slope is minus 2. Okay, so our slope is minus 2. That means that we go like this, and like that, and like that. So this one might work out a little better. So as we look at what it looks like, I'm having trouble. Okay, so got our line, and we said it looks like we found 2 points of intersection. And the one point is 2 minus 1. And the other point appears to be minus 1, 5. Okay. And so you say, well, let's try it with algebra. Let's try it with algebra. Okay, so let's just grab this and see if we can pull it over here. Oops, that didn't work. Okay, so we're going to set those two equal. So we say, all right, let's set it equal. Minus x squared minus x minus 5 equals minus 2x plus 3. All right, so we say, well, let's get everything on one side. So we're going to add 2x, and we're going to subtract 3. So we're going to add 2x, we're going to subtract 3. Let's see what we get. So we get minus x squared plus x minus 8 equals 0. And, that hurts my brain to think about. So let's divide everything by minus 1. Okay. The 0 doesn't care if you divide it by minus 1. Okay, so now we have x squared minus x plus 8 equals 0. And again, that does not look like it's factorable, does it? Does that look like it's factorable? It doesn't. And so I'm just going to check. So let's just double check. So if we look at our points here, let's see if the points actually work. So we see a point at minus 3, minus 1. Let's see if that's a point. So minus 3, minus 1. So minus 3, minus and minus 3 squared, minus 9, minus and minus 3, plus 3, minus 5. And so that one worked fine, right? So minus 3 gives us a value of minus 1. It doesn't look like it, does it, right? So that does not look like minus x squared. Maybe I have the graph wrong. Minus, no, it's okay, it's minus 9. Minus 3 plus 3, so it's minus 6, minus 11.